Okay, welcome to the review for secondary 3. If you were watching this and you were part of my A3 class, I apologize. I won't be here tomorrow. Hold on. Pause. Okay, yeah, I'm not going to be here tomorrow. I'm really sorry. My babysitter's kids are sick, so my kids have nowhere to go. It's kind of the nature of a working mom. I'm so sorry. So here's my good luck vibes. As we go throughout the review, I'm going to kind of circle the ones that you really need to know for the test. I realize this is getting on here kind of late, but better late than never, I guess. I don't know. I'm really sorry. Okay, so let's look at number 1 through 4. On this one, when you have to find each real root, on number 1, the answer is only 5 because you are not putting the square root on it yourself. It's already there. So that's the principal root, indicating only the positive answer. Same with this one. The square root of 0.49 is 0.7. There's not a whole lot of work to show here. So you can just write your answer. The reason why this one is -2 is because -2 times -2 times -2 is -8. And then looking at number 4, this is kind of the same thing. Inside the radical, we're just looking at 8, so it's 2 times 2 times 2, and then you stick the negative out in front. So final answer is -2. Alright. Let's look at the next line then. Simplify each radical expression. Use absolute value symbols when necessary. If I look at this line, you have to know how to do this problem. You have to know how to do, maybe that's the only critical one for this row. No, hold on, pause. You should also know how to do this problem. I mean, the other ones are very similar to it, so I'm not really being very specific. So on number 5, the square root of 81 is 9, and then x. Then you have to decide if you need an absolute value. Because there is an even index, I need to make sure everything that comes out of the radical is positive. X is kind of the, I don't know, the switcher there. It could be negative, it could be positive. So I'll put absolute value signs on there to ensure that that stays always positive. Now looking at the next one, I wouldn't have to worry about absolute value signs at all because that will always be positive. Taking the cube root of that one, 64 is 16 times 4 and then 4 and 4. So I've got a group of 4s. So my answer would be 4x. And then I've got 2 groups of 3, 4x squared. No absolute value. And number 7, looking at 16, I need to look for groups of 4 this time because the index is 4, which is right here. So my answer is 2x. Now the index, or sorry, the power is 12. So how many groups of 4 do I have in 12? There's 3 of them. And again, I have an even index. I have to make sure this x variable will always be positive. So I'll stick absolute value signs around it because the cube would not get rid of any sort of negative if there was a negative involved. All right, number 8. Before I do this problem, I want to simplify everything inside the radical. So you look inside of here first. And anything that can reduce, I want it to. All right, we're going to backtrack a little bit. There we go. So I noticed that the 9 and the 36 will cancel. So this is really saying the square root of x to the 4th over 4. You can't have any radicals in the denominator. And right now the 4 is in the denominator inside the radical. For this particular problem, I can take the square root of 4, and it's just 2. And then in the numerator, I have x squared. All right, looking at the next line, from this line, the ones that you really need to know how to do, I mean, there's like 9 and 10 are the same. So when I say you need to know how to do number 9, I'm also saying you need to know how to do number 10, right? So you need to know 9. Ooh, that was big. You need to know, I mean, the rest of them are kind of the same. So, yeah, you need to know all of them on their own are pretty much the same. Yeah. Okay, this problem. They both have the same index, so I can multiply together. 9 times 3 is 27. And the cube root of 27 is 3. Number 10. They both have the same index, so I can put them underneath the same radical. And I don't know what that is. Hold on. $343. Now what times what is negative 343? Well, 7 make the 343. And if I need a perfect group and I want it to be negative, they all would have to be negative in order to get your group of 3. So that is negative 7. I guess you really kind of need to know that, how you can bring a negative outside the radical. Number 11, let's put it underneath the same radical. I've got the square root of 16x to the 4th. Square root of 16 is 4, and then x squared. I care about looking for absolute values here because the index is even, but because the power right here is even, I don't have to worry about the absolute value. Dropping an absolute value when you need one, or putting one in when you don't need one, would cause you to lose full credit on the problem. All right, number 12. The 5 just kind of hangs on outside. It is a cube root. Because it's a cube root, we don't care about positives and negatives. I don't know if those are multiplied together, but I might just do the tree thing right now. It's kind of fast. And then you would have y cubed, right? All right, let's look for our groups. We'd have a group of 3's that come out, a group of 2's that would come out, and what do we have? 2 times 3 times 5 is 30, and then I have a group of 3's right here, y. There's no radical left over because everything had a group, so 30y is your final answer. Looking at number 13. In this line, there are questions, I don't know, I mean there's a question like that, there's a question, I guess sort of like that. It's a really good review. It reflects very well the problems on the test. Okay, what's 13? Like I said before, we simplify inside the radical first, and 128 divided by 8 is 16, which equals 4. Number 14, since they both have the same index, we can put them underneath the same radical. Ignore this. And now let's start simplifying. So there's a couple ways to do this. 3 and 81, that will cancel. And we'll just write the first step out. 81 divided by 3 is 27. And then this x squared and this fifth will cancel. X cubed, you just need to know to subtract those, and then y cubed. Conveniently, there's nothing left in the denominator, So I don't have to rationalize anything. We just have to start breaking up groups. The cube root of 27 is 3. I've got one group of x, one group of y. Because it's a cube root, I do not need absolute values, so we're going to call that good. Number 15. This one looks a little tricky, and it confuses a lot of people simply because the denominator doesn't have a radical. So how do you simplify it? This still has a radical though, so you might as well break up the numerator. You have 5 x's, 2 groups come out, square root, 1 group stays in, and then you have 8x squared on the bottom still. Once you break things up, these are all connected by a multiply. So it is fair game to start canceling them off. You aren't killing any math teacher by doing that. All math teachers survived this problem. So my final answer, those cancel, are the square root of 3x all over 8. And number 16, this one's a little bit trickier. When you put this inside of the same radical, let's start canceling things. The 2 is still in the denominator. Now there's 2 ways to look at this. I'm going to look at it maybe taking the long route, but hopefully this makes sense to you. Now the 6 and the 5, there's a little 3 here still. The 6 and the 5 don't reduce, so we'll just put them in there. I don't know if I've got room for this. Now on the x's, I have 2 x's from the top that will cancel with 2 x's from the bottom, so I'm going to call it x to the 5th. Now there's something you could have done different there. I'm not going to right now. You can, I don't care if you do it, I just don't want to explain why and how and whatever. The last thing that you can do is there's one y here, there's one y here, so it's y cubed. Now, this time we still have numbers inside of our denominator, so we have to rationalize the denominator. I'm looking for groups of 3 because that's the index. So if I'm looking for groups of 3, I need to have 2 more 5s. If I put in 2 more 5s, I now have a group of 3 on the denominator, but if I put them in the denominator, I have to put them in the numerator. And then the last thing to do is I took out one too many x's. If I would have left one of them alone, then I would have had a group of 3 on the denominator. So let's just add that back in there. It's not a big deal that we took too many out, we just add it back in. So final answer, this still is a little bit tricky. In the denominator, the 2 stays, the group of 5s come out, and then I've got 2 groups of x's, because there's 6 total, right? So the 2 groups of x's will come out. In the numerator, I've got a cube root, the 6, the 5, the 5 make a 150. The x is in there, but what about the y's? There's a group of 3 y's right here, right? So we don't want to put it inside the radical. We're going to take that group of y's, write it outside the radical. Ooh, and this is not quite done. Anyway, we'll write it outside the radical. The last thing to do is this 2 and this 5, I'm not going to rewrite it. This 2 and this 5, multiply them together to get a 10. All right, if we look at the 17 through 19, just the ones that we can see right now. I don't know. You got to know how to do it. There's nothing super secret, I guess. There's problems like all of these. So, oh, my battery's going to die. Hold on, pause. Why is it going to die? Okay, so here's your extra credit. For your extra credit, I am recording this video in my classroom at 6:16 p.m. If you want to get extra credit, you need to tell me what time it was I recorded this video, and you need to tell me thank you for taking time out of my personal life to make you a video. Just kidding, you don't have to say the thank you part, but you could, because it's Christmas, and that would be the nice thing to do. Alright, number 17. let's add or subtract these. You can't add or subtract them unless they have the same radicand, the number inside. So before we can even move on, I have to know that 27 is 3 square root 3. Now if this is 3 square root 3, these two numbers combine and make a 30, right? And then you have the square root of 3. You cannot add or subtract them if they don't have the same radicand, meaning the number inside the radical. Let's do the same thing with this one. 12 is 3 times 4, and 4 is 2 times 2. So I've got a group of 2s, a loner 3. This is 2 square root 3. And we take those two numbers, subtract them. Now if you combine those together, you get 22 square root 3. Because they have the same radicand now, the number inside the radical, you can combine them together. Alright, number 18 is just like number 17. I'm going to take the 20. 20 is 2 times 10, and 10 is 2 times 5. So this is 2 square root 5x. So the x stays in, that's fine. Combine these together, you get 6 square root 5x. What about here? The 45 is 5 times 9, and 9 is 3 times 3. So this is 3 square root 5x. Combine those. And the last one doesn't reduce. So when we add these all together, I've got 6 and 24 make a 30, minus 4 is 26 square root 5x. Alright, number 19, same thing, except for this time we're looking for groups of 3. So 54 is 2 times 27, and 27 is 3, 3, and 3. So this is 3 cube root of 2. And then you have this group of x's right here. So it's 3 cube root 2x, or 3x cube root 2. Sorry, I did that backwards. 3x cube root 2. Now if you're looking at the 16, 16 is 2 times 8, 8 is 2 times 4, and 4 is 2 times 2. Group of 2's loner 2, so minus, the group of 2's come out, the group of x's come out, the loner 2 stays in. These radicals are called like radicals. I forgot to write something. These radicals are called like radicals. And a like radical is kind of like a like term with variables. These don't change, and we can add those together. So 3x minus 2x is x times the cube root of 2. Moving on. Now on this we need a FOIL or multiply. 3 times 4 is 12. 3 times the square root of 2 is plus 3 square root 2. Multiply that way. Plus 4 square root 2 plus 2. So it's like the square root of 4. Add those together, you get 14 plus 7 square root 2. Yes. Okay, number 21. This is actually a difference of squares. So we expect our answer to be a single number. And I know it's a difference of squares because I have a perfect square with a perfect square. Or sorry, I have the identical terms on the front and on the back. And one is negative, one is positive. So when that happens, you're going to reduce everything down just to a single number. So let's watch it happen here. The square root of 5 times the square root of 5 is 5. The square root of 5 times a negative square root 11 is minus square root 55. Multiply these. Now you have a plus square root 55. Minus 11. So those cancel. And you are left with 5 minus 11, which is negative 6. Number 22. Do the same thing, but just distribute. Now, it doesn't look like there's going to be anything that combines this time, but there could be. Let's find out. Minus 10 root 3 plus 10 root 6. You cannot combine those because one has a root 3 and one has a root 6. So you can't combine those. And then you have minus, I'm going to do this off to the side, minus the square root of 18, but 18 has a 9 in it, so I know that it can break down. So minus 3 root 2. Even with a 3 root 2, is there anything you can combine together? No. All right, 23, divide and rationalize all denominators. On this one, I have to get rid of the square root of 5. The only way to do it is to multiply the top and the bottom by the square root of 5. When you do that, on the numerator, you distribute, and you would get 2 square root 5 plus 5 all over 5. Number 24, on this one is a little bit trickier. I'm going to probably need a little bit more space here, so let's get rid of all of this stuff. With number 24, you need to multiply by the conjugate. You have to multiply by something that's going to get the square root out of the denominator. In this case, it was a monomial, so if I multiplied it by the square root of 5, it cancels. You don't have to multiply by the negative square root of 5, just the square root of 5. On this one, 1 minus square root 8, 1 minus square root 8. Now the denominator is going to be the easiest, so let's just do that right now. 1 times 1 is 1, and then you have a minus square root 8 plus square root 8, which end up canceling, and then you have a minus 8. So cancel, cancel, you have 1 minus 8, which is a negative 7. I think on the test, when you do this problem, you're left with a negative 1. Maybe I'll do one kind of like that and show you what happens at the very end. You can see what happens at the test. Because I don't ever really want the denominator to be negative. Okay, let's look at the numerator now. It's a little bit harder. And then we'll put this underneath whatever we get here. 3 times 1 is 3. Let's really quick change this. Instead of saying the square root of 8, what is the square root of 8? Ooh, wow. The square root of 8 is 2 square root 2. So if I simplify that right now, I might have an easier time. So 3 times 1 is 3. 3 times a negative 2 square root 2 would be a negative 6 square root 2. Because the whole part would multiply by the whole part. Okay? And instead of saying the square root of 18, what's 18? I don't know where to put it. 18 is 9 and 2, 3 and 3. So it's 3 root 2. So, instead of saying this, I'm going to say 3 root 2. And hopefully that makes my multiply a little bit easier in the end when I, yeah. So multiply this. 3 root 2 times 1 would be a plus 3 root 2. And then 3 root 2 times 2 root 2 would be a minus 6 root 4. What is root 4? Square root 4. This is the same thing as saying minus 6 times 2, which is the same thing as saying minus 12. So this right here, let me highlight it, this right here is a minus 12. to the minus 12. So let's rewrite what we've got. I've got this 3, I have this minus 12, combine them together and get a negative 9. And then combine those and get a minus 3 square root 2. Now this is all over negative 7, right? I really don't like all those negatives. I was supposed to find out if that's just a personal preference or if we should divide them out if that's a rule. So just assume that it's a rule because the person who's grading has a massive irritation towards negatives. So is it possible to divide each of these by a negative? Yes, I don't want the denominator to be negative. It's annoying. So 9 plus 3 root 2 all over 7 is your final answer. If you left the negatives in there on the homework assignment, I probably wouldn't mark it wrong. On the test, if you could remember to take those off, though, that would be fantastic. Okay. Next one. We're talking about rational exponents. So this is all of the information after the test or the quiz that we took. If you're looking at these problems, the ones that you need to know how to do are all of them. Please know everything. Okay, 25. And this is like saying the square root of 25, which is 5. This is like saying the fourth root of 81. 81 is 3 times 27, which is 3 times 9, and 9 is 3 times 3, so this is 3. There's not a lot of work to show on that one. I would appreciate this tree thing right here. This one's a little bit harder. This is the same thing as saying the cube root of 16, and 16 is 4 times 4, times the cube root of 4. If I put those underneath the same radical, you get 4. And number 28. Another way to look at this is if they have the same base. That number would be the radicand. If they have the same radicand, you can add the powers. So for example, x squared times x to the 4th equals x to the 6th. Nothing happens to the x's. You just add the power. Same thing here. I have 5 to the 3/2 times 5 to the 1/2. That's like saying 5 to the 3/2 plus 1/2, which is 5 to the 4/2, which is 5 squared, which is 25. Oh, what just happened? Sorry. Surprise, which is 25. This is the time that I want you to show some work. Whether you keep it with the exponent or you change it to the radical, I don't care, but you cannot plug this into your calculator and expect to get any credit. So please make sure that happens. Let me flip to a new page really quick. There is one thing I want to show you. Make sure you know how to do it. Okay, 2 things. So this isn't on your review. It's just kind of a helpful piece of information. If you have 5, hold on. If you have 5 to the 1/2 times 5 to the 1/8, how would you simplify that? Is that what I want to do? Yeah. How would I simplify that? Yeah, I think so. To do this problem, you would have 5 to the 1/2 plus 1/8, right? In order to add those together, you have to have a common denominator. So this one I need to change. Instead of saying 1/2, I'm going to call it what? It has to have an 8 on the bottom. And what's the equivalent fraction to 1/2? It is 4/8. So this would be 5 to the what? 5/8. And I will leave that as my final answer. If the problem is given to you in a radical, you have your final answer be a radical. If the problem is given to you in a square root, or I'm sorry, in an exponent, I want your final answer to be an exponent. The other thing I want to look at really quick is this problem. How would you simplify this? Let's try. Like that. So if I gave you that problem, what would you do? And the correct answer is I have to multiply by the conjugate. The conjugate would be the square root of 2 plus the square root of 3. Okay, let's deal with the numerator first. Multiply those two. And remember, I'm telling you this for a reason. So 5 square root 2. Multiply those two, you would get 5 square root 3. Multiply those two, you would get minus the square root of 10, which doesn't break down. And multiply those two, you would get minus the square root of 15. It is okay to have one nice, long, ugly thing up there. That's fine. Looking at the denominator, this is a difference of squares, so you expect the middle two terms to go away. Plus the square root of 6 minus the square root of 6, it does. And then minus 3. So what number is in the denominator? -1. This is, again, one of those times where you have to do something to the denominator so it's no longer just sitting there as a -1. Something has to happen. Could you divide each of these terms by a -1? Yes, and when you do that, this becomes negative, this becomes negative, this becomes positive, this becomes positive, and that becomes positive. It will change the signs of each of the 4 terms. So your final answer, and you will lose points on this one if you leave a negative in the denominator like that. That would be your final answer. All right, let's go back to the review. Now we're sitting at number 30 or 29. All right, make sure you use absolute values. This one is a 4th root, right? Oh, that didn't work. This is a 4th root. When you have a power raised to a power, you multiply. So when I times those together, I get x to the first, which is just x. Now, because of the even index, I have to guarantee that my x always stays positive. This time, I have an odd index. This is the same thing as saying the cube root of -8 y to the 9th. You could look at it that way. Well, what's the cube root of -8? We did that up on the top of the page. So it's -2. And then how many groups of 3? That's easier than the way I did it in class. I'm sorry, I should have just done it that way. All right, this one is, however, easier, multiplying the powers. When you have a power raised to a power raised to a power, you multiply those powers. So what's 1/6 times 18? 1/6 times 18 is a -3. And what's 1/3 times 18? It would be a -6 because it's a -18. Now, really quick, which of the indexes is even? The one that I have to worry about absolute values on is the x cubed. I don't care about the y because the y has an odd index. If I rewrite that, what does the negative do? The negative moves the fraction to the denominator, or moves the x term to the denominator. The negative here does the same thing. If you want to put a multiply, you can. The last thing to note is that because this is an even index, this is an odd power, please make sure that is absolute value. All right, 32. There's a couple ways to look at this one. I probably would raise the power to a power, so take care of those. What's 1/3 of 9? x cubed. And then take care of those. Ooh, what's 9 times 2/3? That would cancel, that would become a 3, and you would get a -6. So it would be y to the -6. Oh, but it's on the denominator, so strike that. Okay, and so now what? This negative is going to take it and move it to the numerator. So you would have x cubed y to the 6th. Do either of those need an absolute value? No, because the denominator is an odd power. All right, next page. Now we have to solve these square roots. We are going to cross off 2 of the options, 7 and 8, because you won't have anything like that on the test. And we didn't really cover it in class. Number 1, let's subtract the 2. So you've got the square root of x plus 5 equals 2. I'm not going to do all of these because they take a long time and I want to go home. But I'll make sure I have at least a couple of every type problems. The next thing you want to do is look at the domain. What values of x would work? I know that x plus 5 has to be greater than or equal to 0. So x is greater than or equal to -5. Whatever answer I get for x, it has to fit in this domain, otherwise it's not going to be a real solution. So if I square both sides, you get x plus 5 equals 4, and then subtract the 5, x equals -1. Now I didn't really worry about this being part of my domain criteria because 2 will always be positive, so it's fine. Fantastic. So, is this -1 fit inside of my domain? It's bigger than -5, yes, so that is my solution. Let's look at number 3. The very first thing I will do is I will isolate my radical, so let's divide both sides by 5. And as I'm dividing, I'm also going to rewrite it so that it's in a radical because it just makes more sense to me that way. Now how do you get rid of a 4th root? You forfeit. I don't know what the right word is for that. Maybe I'll find that one day. You raise it to the 4th power, I think is the technical terminology. So on the left, really quick, we did not look at the domain, so let's take care of that right now. Because it's a 4th root, I have to make sure that it has to be positive. What kind of root does it not matter? If this were an odd number, it wouldn't matter. My domain would be all real numbers. Do we have one of those? Yeah, number 4. The domain of number 4 is all real numbers because that 3 right there is the index. So it doesn't matter what x is on that case. Jump back to here though. Keep solving, subtract the 1. 3x has to be greater than or equal to -1, which means x has to be greater than or equal to -1/3. Okay, let's 4 both sides. We did that. I get 3x plus 1 is equal to 16. Subtract the 1. X is equal to 5. Okay. Next row, let's do number 4 because it's a really good test question. So like star it, make sure you know that this is a really good test question and you need to make sure you understand it by tomorrow. The very first thing I would do is isolate the radical, so divide by 4. And as I'm rewriting this, I actually want to put this in radical form, so it is a cube root, and then the squared goes down here with this bugger. Okay, so now how do you cancel a cube root? You cube both sides. And you're left with 3x minus 3 squared equals, I don't remember, 279 or something. 279. No, 729. I can do math. 729. The domain is all real numbers. Anything would work because it's a cube root. Now what? We have to get rid of the squared, and the opposite of squared is the square root. Well, what do you do when you take the square root? You have to, if it was x squared equals 100, you would take the square root and you would say x equals plus or minus 10, right? You've known that for a long time now. Same thing here. When I'm taking the square root, because I am the one putting the radical on it, I need a positive. But I also need a negative. There's going to be two answers here because of the plus or the minus. There is another way to do this. You could actually play the game. You could multiply this out, subtract the 729 over, and play the game, and it ends up being a very miserable experience. Ask Austin Love. That's the way he did it. It works totally fine, but it's not fun to do. Okay, let's add the 3. That goes away, so you get 3x equals 30, which means x equals 10. On this side, if I add the 3x equals negative 24. Divide by 3, x equals negative 8. Do both of those fit inside of our domain? Well, our domain was all real numbers, so I would say yes. One more, number 6. On number 6, let's start by subtracting the 2. So you have the square root of x plus 6 equals x plus 4. And now we have to look for the possible x values. From the radical, this x plus 6 has to be greater than or equal to 0, which means any x value that you plug into the radical has to be bigger than negative 6. That's the first part. The second part, x plus 4, has to be greater than or equal to 0. This number right here also has to be positive. You won't ever get a negative square root. That means x has to be greater than or equal to negative 4. If I'm looking at a number line, I have 0, I have negative 4, I have negative 6. One of these domains said x have to be these values. The other part of the domain says x has to be these values. Really, you're looking for the overlap, because it has to fit both of these criteria. Because it has to fit both of those criteria, I'm looking for all of these values in that direction, which means this is the domain I'm referring to. And that one is too loose, not restricted enough. Now how do I cancel the square root? This is already isolated, so let's square both sides and be very careful. I have to square the whole thing. On the left, those cancel. On the right, when I rewrite this, I have x times x, which is x squared, plus 4x would be plus 8x. I did that quickly, did you see it? So plus 4x, and then plus 16. I'm going to want to play the game eventually, but before I can do that, I have to get rid of those two on the left, move them over to the right. If we're talking potential test questions, this is a potential test question. Then you have, subtract the x, you get 7x. Subtract the 6, you get 10. Then you still have your x squared. And then we play the game. So on this one, what multiplies to 10 and adds to 7? Five and 2. And if I'm going to set it equal to 0, either this one equals 0, or this one equals 0, and that's that page. Moving on. 7 and 8 we cancel, but let's look at number 9. It is also a very good test question. So please make sure you know how to do it. On this one, there's two variables. I mean, they give you an equation, that's nice. The equation on the test is a little bit uglier, but there's still, let me see. There's still just two variables. In the problem on the test, it's dealing with radius and volume. On this one, it's dealing with power and radius. Kind of the same thing. I mean, not the same thing, but the same difficulty. The power P in watts that a circular solar cell produces, like I don't care about any of that, and the radius of the cell R, so really this is what matters, and this is what matters, right? In centimeters are related by the square root equation, yada, 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 yada. About how much power is produced, so this right here tells you the variable to solve for. By a cell with a radius of 12. That means everywhere there's an R, we're going to put a 12. 12 equals the square root of P, that's the variable we're solving for, times 0.02 pi. Let's square both sides. So you get 144 equals the square root, nope, just kidding. The square root goes away, so P over 0.202 pi. And then to get rid of the 0.02 pi, let's multiply both sides by 0.02 pi. Now this is where things get, I don't know, not hard. Those cancel, P is by itself. We don't normally multiply the pi through because pi is a really ugly number. I mean, it's irrational, it goes forever, and your decimal looks horrendous afterwards. If you multiply these two together, you just get 2.88. So I'm going to say the power is 2.88 pi. If you wanted to plug that into the calculator and get like 8 point yada yada ugly, you could. I wouldn't mark you wrong. I'll just tell you that the answer is ugly. That's fine. Okay, on this last page, you have to be able to, let's see where to put my test. You have to be able to, there's nothing tricky, add, subtract, multiply, divide. And then I want you to state the domain of each of these operations. So number 10, well, really quick, remember that domain restrictions happen if there's a denominator or if there's a radical, right? That's the only time right now that you're going to have a domain restriction. If I look at number 10 and I simply want to add this together, you can list them like that if you wanted to. I didn't put them in the same order, I flipped them, that's okay. X squared plus x minus 20 is your answer. The domain is all real numbers because there's no denominator, there's no radical. Number 11, subtracting this time. So g of x, x squared minus 16 minus f of x. We have to distribute the negative. So you'll have x squared minus 16 minus x plus 4 this time. All real numbers. There's no denominator, there's no radical. Now let's multiply. There's two of these. Two of these 4 questions will be on the test. Only 2. So multiply them. I'm going to do this a little bit tricky because I want to make sure that when I multiply them, I have it written in standard form when I'm done. So I've got x squared times x, which would be x cubed. And then x squared times the negative 4 would be a minus 4x squared. Now, I'm going to multiply these two, minus 16x, and then multiply these two, plus 64. It's in standard form. There is no denominator, no radical, so all real numbers is my domain. And my last one, number 13, g of x over f of x. G of x is x squared minus 16. and f of x is x minus 4. So now my domain's different because there is a denominator. What's the excluded value in that denominator? The domain can be all reals, except what? X cannot be positive 4. Because if it were, this would be 0, and then it screws everything up. So always do your domain before you cancel. Now I need to factor the numerator. This is just like unit 4, I believe, at the beginning of the quarter. X minus 4, x plus 4, that's this factored. Multiplies to a negative 16, adds to a 0, and then we have something cancel. Assume that if there's a division, it cancels. Yes. I think, hold on. 6 and 2 minus 6 plus 2. Yep, assume that it's going to cancel if you by chance saw this on the test. So my final answer would be x plus 4. Alright. Last question, let g of x equals 5x minus 2 and h of x equals x squared plus 1. Find the value of each operation. This is h of g of negative 1. Well, let's find g of negative 1 first. I believe that's negative 7. Then we're going to take that g function, we're going to replace it right here. So h of negative 7 would be negative 7 squared plus 1. 49 plus 1 is 48. Next one, h of g of 0. H of g of 0. Well, g of 0 is 5 times 0 minus 2, which is negative 2. Sub answers, I guess. Take that negative 2, plug it in here. So h of negative 2 is negative 2 squared. 4 plus 1 is 5. Number 16, g of h of 2. G of h of 2. Find h of 2 first. Sorry, sometimes when I'm finished, I think that I have just a bunch of math vomit on the board. Kind of looks that way, I'm sorry. H of 2 is 2 squared plus 1, which is 5. Now we're going to take that h of 2 and we're going to plug it into the g function. So 5 times 5 minus 2. 25 minus 2 is 23. Last one, and then we will peace out, and I will see you another day. G of h of a. A little bit different. Let's start by finding h of a. H of a would be a squared plus 1. Then we're going to take this a squared plus 1 and plug it back into the g function. Not as friendly, but it could be worse. So that's 5x minus 2. Distribute. Final answer, 5x squared plus 3. Alright, I hope that what I've shown you is helpful. You know what you're doing. Don't second guess yourself. Be confident. You guys are far above the students I had last year, and I loved them, so don't tell them I said that. But your ability is far surpassed theirs, so you can do this. And thanks for watching. Peace out. Bye, guys.